Hello world viewers, what's up? I hope all you are doing well. And on yours and yours are also doing well. In the previous video, I told you that I have derived the first equation, and in this video, I am going to derive the second equation, that is divergence of B. I don't want to waste the times because times are very precious to me, you, and everyone, right? So let's go to the direct work. What is the second equation? That is the divergence of B. We have to derive it. Okay, I will write it here. Divergence of B is equal to 0. Okay, divergence of B is equal to 0. So it's based upon the which principle? It's based upon which principle? It's based upon Gaussian law for the magnetostatic. Gauss law for the magnetostatic. It's based upon Gauss law for magnetostatic. And in the previous, that Gauss law for the electrostatic, here it is the magnetostatic. What is the statement for it? I'll do it the mathematical section and you can write it in the theoretical. There is no need of any kind of things. That is surface integration of B dot ds is equal to 0. This is the statement of the Gaussian law for the magnetostatic. So what happens here? I just want to analyze you. I just want to symbolize you. I just want to understand you again, because it is happened in the 11th-12th class already. Okay, so it is B dot ds. What happened here? In a closed surface, let's say this is a closed surface. Okay, because it is a closed surface, let's say this is the part and it is, we call the ds. Let's say there is 5 magnetic field are passed out, 5 magnetic are passed out, and all the 5 magnetic fields will also pass out because there is nothing inside in between that. That's why the magnetic flux inside that is always 0. It is also called the magnetic flux is 0. This is the same statement in this way or this way, it is 0, because in various kind of books you will find various kind of definitions, but the sense and the meanings of the definitions are always equal. The magnetic flux inside a closed surface is always a 0. Always a 0. That means here it is 0, here it is also 0. So in the right hand side we don't need to worry because the statement itself says that magnetic flux inside a 0 always. So what is B? B is the magnetic field, and what is the formula for B? That is magnetic flux upon area. Magnetic fields upon area. This is the magnetic field, this is the magnetic flux, and this is the area part. So it is the formula for it, and when the magnetic flux is 0, that means the B is also 0. So no need to worry about that. In the next stage we will do this much. We need to find a divergence inside it. We have to get a divergence. How can we get a divergence? By Gaussian law for Gaussian theorem. We will use Gaussian divergence theorem. We will use Gaussian divergence theorem. Apply Gaussian divergence theorem. What it tells? It takes surface integral into volume integral, and volume integral into surface integral. It is its function. It is an instrument. It is a function of that instrument. Okay, it is a function of that instrument. So if that is the instrument and that is the function, then what will happen here? Well, here the surface integral will be converted into volume integral. What will happen next? Let's see. So it will do volume integral V. I'll write V. Okay, so it will be the B. The B will be divergence of B, because when we go to the surface to volume or volume to surface, when we go to the volume to surface, then divergence will be removed out. When we go to the surface to volume, divergence come out. It comes and it reflects here. So it will be divergence of B dV is equal to 0. Is equal to 0. Okay, is equal to 0. So here these two are the constant. B dV is equal to 0. This much is V, and if the V go to the right hand side, it will be 0 actually, because in the right hand side there is 0. 0 divided by something is always 0. 0 divided by something is always a 0. We are right, except 0. Okay, so it will be divergence of B is equal to 0. Divergence of B is equal to 0, right? So how it looks to you? Derivation is completed. I just want to tell you some additional point of it. In case of magnetic field, there is a very good relation between the electric field and magnetic field. You know, electric field are passing. Let's say the electric field is passing and the electric field is passing. At the same time, there is magnetic field also happening. In the magnetic fields are also happening at the same time. They are 90 degree. Okay, they are 90 degree. They creates 90 degree between themselves. EM wave, electromagnetic waves. We know it. We know it. These are the 90 degree symbol. Okay, 90 degree symbol. Just doing like this. They are going on the right side. They are going on the top side. So they are going in the 90 degree angle. So and that dot product is always a 0. We all know it. And when in case of a magnetic pole, it is the north state. Let's say this is the south, and the magnetic fields lines are always comes from the north to south, north to south, north to south. Okay, north to south. Okay, north to south. Every time, 3, 4, 5. So the magnetic fields are always go to the north to south direction, north to south direction, north to south direction. If I take any kind of closed loop in between them, I take the closed loop. Let's say this is the DS, I can say, or whatever. If the closed loop in between them and it is the closed surface, then there is no difference. Can't any vary. It can't vary the magnetic field. It will go to north to south. It will go irrespective what you put inside that. If that closed surface, then there will be nothing inside this because all will be diverse. All will be diverse. Pass through it. Will be pass through it. That means in between that there is nothing. Magnetic fields. That's why the magnetic flux inside this always 0. Always be 0. When you will put any kind of closed surface in between the magnetic field, it will always be 0. It will always be 0. This is the simple statement or simple style. It is over. In the next video, we'll discuss about the third equation. Okay. For it, thanks you for watching this video. Don't forget to comment, share, and subscribe. Thank you.